Hi everyone, it's Johnny again. In my previous videos, I have talked about 4 primitive data types in Python, and they are integer, float, boolean, and string. In my next few videos, I will start talk about some collection data types. Specifically, there are 4 in Python, and they are list, tuple, dictionary, and set. The biggest difference between the primitive data type and collection data type is that a primitive data type can only store one value, while a collection data type allows you to store a collection of data. It will be more clear once we see some examples. In today's video, we are just going to focusing on list. So first, let's see how to create a list in Python. Python lists are created using square brackets. So I have created 5 different lists over here as an example. List number 1 contains all integers. List number 2 contains all float values. List number 3 contains all boolean values. List number 4 contains all string data types. And then list number 5 contains a mix of the data types. So as you can see, a list is just a collection of values, and you can have a mixed data type within your list. You are not bounded to have a consistent data type. So right here, I'm typing all the data type in list 1, 2, 3, 4, and 5. And then you can see that they all belong to this class list. And if we just print out the values of individual lists, then its elements will just be printed out. So that's how we create a list using square brackets. Now let's talk about how to access or update elements inside a list through indices. So in Python, the first element has an index 0. So if you want to access the first element inside a list, you need to pass a square bracket, and then inside the square bracket, the index should be 0. The first element of list 1 is 4. If you want to access the second element inside list 1, then you need to pass index 1. So the second element inside list 1 is 6. You can also use negative index. Negative index simply counting the index from the end of the element. So -1 means that you want to access the last element inside your list. So the last element inside my list 1 is number 10. And if we pass -2, then we are going to access the second to the last element inside list 1, which is 3 in our case. You can also select a range of elements using column. So in this example, I'm selecting list 1 from index 3 to index 6. Notice that when you select a range of elements using this column notation, Python will select the element of the first index, but it will exclude the element with the second index. So just make sure that you remember that. You can also use negative indices to select a range of values. So in this case, -4 to -1 is equivalent to 3 to 6. Now, if you are selecting from the first element, you can actually omit the first index 0. So right here, I'm printing list 1, 0 to 7. And then the second line, I'm omitting number 0. And as you can see, we will get exactly the same thing. On the other hand, you can also omit the last index if you are selecting through the end of the index. So over here, there is another example where 3 to 7 is equal to 3 column without the last index. And if you want to update some elements, you simply select the index and then put that equal to the number you want to update it. So in these small examples, I'm updating the second element to be 0. The original list 1 has 4, 6, 6, 7, 1, 3, 10. Once I update the second element to 0, then the second element turns to 0. Now let's talk about some commonly used list functions. First function is the length function. The length function allows you to check the number of elements in a list. So in our case, list 1 has 7 elements. A second function is if you want to add an element to the end of a list, you can use this append function. So in these examples, I'm actually appending 100 twice inside list 1. And as you can see, the first output is the original list 1. Once we append 100, the second output will have 100 at the end of the list. And then if we append 100 again, then there will be another 100 appended to the end of the list. If instead of appending one element, you want to append another list to the end, you can use list.extend function, or you can use the plus sign. So in this first example, I'm using the .extend function, and specifically I'm extending list 1 to list 2. So the original list 1 has 4, 0, 6, 7, 1, 3, 10, 100, and 100. Once we extend it with list 2, then the 3 elements in list 2 will be appended at the end of the list. As another example, we can append list number 2 and list number 3 using simply the plus sign. If you want to insert an element inside a list, you can use list.insert functions. So .insert function has 2 parameters that you need to pass. First is which index do you want this element to be inserted, and then the second parameter is what value do you want that inserted element to be. So in these small examples, I'm actually putting 2 insert. First output is the original list 1. Once we insert 999 at index number 3, you can see that 999 is inserted to be index number 3. And then everything after that will be pushed back 1 index. And then I'm inserting 999 second time, but the second time I'm inserted to be index number 5. So on the third output, you'll see that index number 5 has 999. And then rest of the elements inside that list will be pushed backward. If you want to remove an element inside a list, you can use list.remove function. So in this small example, the first output is the original list 1. Once we use .remove 999, as you can see, the first 999 is removed. So this .remove function only removes the element once, and it only removes the element that has the lowest index. So just keep that in mind. If we remove 999 the second time, then the last output will no longer have any elements that equals to 999. Now if you want to remove an element with a specific index, you can use this .pop function. So for example, in my first output, I am printing out the original list 1 values. If I want to remove the second element which has index 1, if I want to remove list 0, I can simply use .pop and then parenthesis 1, and then the second output is the result. If you want to check an index of an element, you can use list.index functions. So for example, in my list 1 right now, I have 100. If I want to know what's the index of this element that has value of 100, I can use this .index 100, which gives me 6. As you can see, it only gives the first occurrence of the 100, which is 6. It doesn't give us the index 7, which is the second occurrence of the element 100. So just also keep that in mind when you're writing some program. If you want to count the number of occurrence of an element values, you can use list.count functions. So 100 happened twice inside this list once. Therefore, if I use list1.count 100, I'll get an output 2. And also you can use list.reverse functions to reverse the order of your list. So first output is the original list 1. Once I use .reverse, then the second output has everything backwards. The last element 3.2 becomes the first element, and then the first element 4 becomes the last element. You can also use .sort function to sort your list in alphanumerical order. So for example, the first output is the original list. Once we sort list 1, then it will sort your list into a numerical order. Lastly, if you want to clear all the outputs to your list, you can use list.clear functions. So the first output is the original list1. Once we use this list1.clear, then everything inside list1 is gone. Lastly, I want to talk about copying lists. Copying lists is tricky. Why do I say that? Because, for example, if you simply copy a list by list syntax, so list2 underscore copy equals to list2, you can see that when we print out both list2 and list2 copy, they have the same values. Now, if I append number 10 to the end of list2, so what happened is, even though we only append 10 to the list2 copy also get updated. Why is that? This is because even though when we print out list2, it output the values of all the elements inside that list, but this list2 variable actually only store the position inside the memory of those elements. So it is simply a pointer. Same thing, this list2 underscore copy, if you set that equals to this list2, then this list2 copy is simply a pointer. So right now when you say list2 underscore copy equals to list2, they will be pointing to the same location. But when you update list2 over here, you are actually updating the actual elements of the list, but the position of the list remains the same. So when you print out the list2, you will get that 10 to be updated, and when you print out list2 underscore copy, the last element of 10 is also getting updated. So if you truly want to copy list2, you need to pass this .copy functions. That way, this list2 copy is still a pointer, but it is pointing to a completely different list inside your memory. So now if we append a value 10 to the end of the list2, it no longer affects list2 underscore copy. So that's basically everything I want to talk about on Python lists. Let me know if you have any questions. You can leave them in the comment section below. Other than that, I will see you in my next video.